Awesome. Here we are. So we have an agenda for this?
Yes. I think you wanted to speak about the comparators.
Possibly, yes.
Comparators?
Yeah, I'll get to that in a sec.
Element value ones.
Yes.
Yeah, I guess. Anything else then? Anything anybody has on his mind?
There's something else I was thinking that I saw in the Ehcache 3 mailing list, one of the commits or something that I thought, but I can't remember what it was.
Okay.
Meh.
Meh.
Because I can't remember, it can't be that important.
Woot. Okay, so let me then introduce, so some of you, well, I discussed with some of you this whole thing of flushing back to the authoritative tier, make sure that it records the updated stats and so forth. And there, so we did say that what we want to do is only make that happen if the mapping that we're flushing actually is pinned. That's the one thing to which we agreed on earlier today, actually. As it turns out, this could be flawed. It's not a problem today, given how Ehcache 3 works, but it, for instance, would be a problem in the 2x line because of how that works. And given the port that we got, there are still methods that are there that expose the flaw, i.e. that lets you shoot yourself in the foot. One of those methods would be put pinned, so that when you populate something that you just blindly go and override into the whole thing. And as far as I know, it's entirely possible to have races there between a flush happening and things like that, which are not a problem necessarily, but could be. As such, where does that all lead? So I started writing it. So as such, I decided to leave the value comparison in the code. And since I was smart enough to use a byte array as the value, well, you guys got the problem. Which led to the question I asked earlier, which was, where do we stand on that? Is everything busted, like a 2arg remove, for instance? And apparently the answer is yes. So, well, busted. Open for debate.
That's not broken. Well,
No, well, yes, exactly. I was about to say define broken. For the flush, it definitely is, right?
right.
Because
Internally, for Flash, it's a problem.
for a 2arg thing, it may not be, but it's the same problem if you want. So,
If there's a problem, yeah.
If there is a problem, yes. So, long story short, is what is it that we want to do about that? And obviously, the thing I care about the most is me, myself, and I. So, I'm mainly talking about the flush here, where I could simply special case things. Should I even bother looking at the value comparator thing at all? Never. What would any of that, if anything, mean for transactional caches, say, for instance?
All right. I could give a bit of background of why the element value comparators were added in Ehcache 2.
I think that's a good idea. That's a good start. I'm going to go on mute. I'm not going to be gone, but I'm running out of battery, so you guys know. I'll be fixing that.
Okay, so there were two reasons. I will start with the second one because I want Alex to hear the first one. So the second one was transactional caches. Yes. The way they are implemented is they are fully lockless. If you remember, that, I don't know, Louis, if you already had a look at that code. Yeah, okay, but the way they work is they get what's in the underlying store and they try to replace with either a put if absent or a to-arg replace or whatever. So we need to be able to compare the value. Of course, it needs to work if the value is an array. You never know. So that was the first reason. Well, that was actually the second reason. The first reason was there is one use case where arrays are extremely important, and that is Hibernate. Hibernate stores arrays as values. Arrays of strings, or can't remember what, or maybe they don't do that anymore, but they used to back in that day. So maybe Alex could confirm or deny that.
Well, I don't know, or I missed some context, but
Okay.
no, the type that goes inside a Hibernate thing is either a map if you use for the value, if you use the whatever mode, the debugging mode that you shouldn't use. Oh, and then maybe yes, then actually maybe yes. I don't remember.
I remember properly, at some point in time, in some version of Hibernate, the value used to be the dehydrated object, which was an
that
array.
still is, but was it wrapped inside another type, or was it directly the array?
No, it was directly an array.
Could well be.
Yeah, and for that to work with transactional caches, of course, we needed to be able to properly compare the arrays. So array comparison was introduced in such a way that two arrays could be compared deeply. And in a consistent way across all the stores.
Why couldn't we do this with a wrapping type? Why did it have to be done with an injected element value comparator?
The reason why it was injected in Ehcache 2 was because of the design of Ehcache 2. We couldn't change what was inside. Couldn't change the element object.
What?
No, actually, yeah. Actually, I think Ludovic is right.
We couldn't change what? Sorry.
The
I think I know the answer
class.
to some of these questions, but I'm purposefully being dumb. At least I'm going to claim that.
In Ehcache 2, to do that without injecting the comparator, we needed to change the element class, and obviously that wasn't possible.
Right, so my understanding is that the main reason for this is nothing to do with the value contracts. The equals method of the value object not being what you want is the equals contract on the element was completely weird because it didn't compare the values, right?
Yeah, there was a bit of that too.
So I'm just wondering how much of this problem is gonna whether the whole problem can't be for transactions. So here's the thing: if the cache is non-transactional, right? As far as I'm concerned, if you have byte arrays and you do to-arg replaces, it's referential because that's how arrays compare. So it's going to break because we're serializing, and I don't think there's any point in hiding that from the user. And if you want to have sensible contracts, then wrap your arrays in something that defines an equals method that compares by quality. And then I'd like to understand if there's any reason why that wrapping approach can't work in 3 for transactional caches.
On top of my head, I can't see a reason why that wouldn't work.
In which case, the only remaining problem.
Well, there is one. There is one.
Alex is flushing.
Yeah. Wait. For transactional caches, there is one. Well, there is one. I'm not sure, and I'm just going to highlight it. Right? It's you only have state that you shouldn't see in your cache in transactional caches when there are in-flight transactions. Right?
Right.
Right.
You can entire a system
yes.
to idle state, and you can decide to use this thing non-transactionally afterwards, and that's perfectly safe.
That is entirely an implementation feature. There is no way I want to support that control.
This is why I said maybe it's not a point, but there is something given my understanding of things at least. That's
Right,
I think what I just said is right, except if something else guards the user from actually being able to
there
do
are
that.
things that guard the user from doing that, at least in clustered.
Well, that's
We store the fact that we actually persist the fact that the thing is transactional in the cluster,
right.
so that you can't gain non-transactional access to a transactional cache and have people poking around in internal state of transactional
There you
cache.
go. Then maybe that's good enough.
I don't know necessarily.
Arguably, there is another advantage to that, by the way, because I'm not sure I mean what I say, but I'm going to say it anyways. So in the new TC world, as we envision it today, this prototype could be shared across a cluster and the client. It could know.
Right. But what do we do with users who want to store arrays?
I mean, what do we do with them? Store
We
arrays
tell
in
them,
where? In a cache or in a transactional cache?
In a cache, in a non-transactional cache.
What do you do with
They
them?
wrap it. What we just said.
Well, no, you don't even have to wrap it. It works.
Oh, okay, yeah, it works.
Yeah.
If you're not, as long as you're not going to use it, and it works exactly as it would normally work in two args, except bar the fact that the serialization pass going through. If you do heap caching, right, pure in-heap caching with byte arrays doing two arg removes and replaces, it works exactly as you'd expect. If you back the cache with a store that does serialization, then yes, object identity is erased. Well, since byte arrays depend on object identity for their equality, suddenly nothing's equal to anything else. But that shouldn't surprise anyone.
Apparently that does. I'm sure that would.
Well, I mean, it's no great. I mean, the fact that when you're using byte arrays, which rely on object identity for equality, that when you do two arg replaces, nothing suddenly ever passes because the identity is being erased and they're not equal, is no different to the fact that you put something in and you get it out and you look at the object and it's a different object.
Yeah, I don't think we should.
There's no way I want to jump to any
code. Yeah, I don't think we should defensively code around that. We should educate. Because exactly as Chris said.
Yeah, I'm
especially
with that,
it does that.
Especially
with the tiering design we have today, where we don't put stuff in the caching tier, we just put to the authority. So if you take an off-heap cache, put an array in, and get it, it's a different instance. If you get it a second time, you get the same result between two gets as long as it's in inside the heap caching tier if you're doing by ref heap. So we can't go around that anyway. That's part of the design. So let's embrace it and be more on the, yes, sure, if you rely on object identity as was just said, and you have a serializing cache, you need to do something, and potentially that means wrapping. And it may mean we want to have a smarter solution when we do Hibernate integration and that kind of stuff. But that's different. That can come on top, just as we've discussed that transaction.
Yeah.
We're thinking of doing them on top.
Yep. Okay.
The other thing to bear in mind is that it really only this behavior only really badly screws with the concurrent methods. And I'm pretty much of the opinion that very few people are going to use these in a pure caching environment. So it's even less important that those things are, I won't say broken, but behave in a way that you might not expect.
Okay.
Okay.
But it leaves
But
the first question.
personally challenged on all that stuff.
So does that mean we can get rid of this comparator stuff that we have, those classes and whatnot that we have in the code right now?
For the moment, it's dead code. Nothing uses it.
Right, so it's just a straight port. It's like those method, like put pin.
It's stuff that I forgot to clean up. Yes.
So heap cache.
For example, I think given the way we've implemented most of the code by using compute, On the Ehcache concurrent off-heap clock cache, remove and replace are never used. You can just delete them. There is currently no call site for them. Not even tests, actually. So they can just be deleted, and if you delete them, then that value comparator is no longer used, and you can delete it also.
Cool. I'll do that.
Well, I think that we're just getting lost in all the history of E2X. I think the main reason that this is here is because the element equals contract is screwed up. Because the other thing to bear in mind is these are not element value comparators in the sense that they take two values. They take two elements and compare the values of those elements, and you had to do that because
the tricky bit is that when you we use generified type, and the off-heap store will be generified with KV, and V is the type of the value. But then the map that you actually use is also generified with KV, but the V is a different V. It's this value holder that also holds all the metadata.
Yeah.
And so when you're not doing a compute method, so when you're not passing a function and the function sees the real type, because the off-heap store knows that the map, the V type of the map is actually value holder of V, where V is the same as the off-heap store one. If you don't pass in a function, then what you're trying to compare internally needs to be cast into something, and then you can get finally to the value. So that's why it was done with a comparator. But since most of the code we end up writing now.
Well, I'm not really sure what point you're trying to make, but I have a question with regards to that, which may explain it all. Why is the abstract value holder equals contract the way it is? Do we really mean this?
I think not.
Right. I'm not saying I think not. I wasn't sure. It was certainly surprising to me.
So currently the equals contract looks at...
It compares the timestamps, if my memory serves, and that's weird now that I think twice about it. I implemented that and I thought after implementation. Shame on me.
Well, no, but the abstract doesn't know anything about the value itself, because the abstract just knows about timestamps.
Yes.
Right. So it's very surprising.
Oh, so yeah. So it probably
No, it's probably meant to be, I guess, abstract, really, and other people are supposed to call super, I guess.
Yes.
But even that, I'm challenging.
No, but that doesn't work.
But it could be busted. That's perfectly fine. But what is it? Okay, then that's good. That's one thing that's out of the way. So what should that contract be?
The abstract?
My take, the contract should be the value and the creation time.
I wondered about that latter too. I'm not sure about that latter, but I'll evaluate the same thing in my head right now.
Can we kill two birds with one stone?
Sure, if you aim very well, you can.
So Alex has this problem that he needs to know if this is the same value.
Right.
And we have this problem about what does abstract value holders contract look like? Why can't we just stamp abstract value holders with sequence numbers derived from keys or UUIDs or something that Alex can use to do pseudo-referential comparison when he's faulting?
And actually, I was going to say that probably is the most efficient way, because the other problem we have is that the representation of the value depends on the tier.
Right, that's the idea I toyed with yesterday, right?
If we could make deserialization of the value lazy.
Oh, that we can.
And I know, and we would have another identity, then we gain a lot.
right? If you carry this, this is how we left it yesterday with Chris, chatting about that. So I came, I said, all right, this suffers from the ABA problem, blah blah blah, and then we said what we could do is actually use some kind of identifier, right? It's much cheaper to serialize as well, right? And just use that to do the comparison, right?
That was, and the first suggestion there was, coincidentally enough, creation time.
Right. And
now, I don't think it's a good idea. I think that you're leaning on the ground clock. But you could certainly have.
Certainly, when you move to clustered, it's going to be crappy. But you could totally have, kind of a sequencer that gets injected.
So who wants to bring back the time stamper? I'm hearing it there.
Actually,
we only care about these things being comparable for things sharing a key, right?
The time stamper is not good enough, by the way, because in the case of clustered, probably you will want to use some bits to do the node identity thing, right? You'll want what? Node identity and then some bits left to do an increment.
The obvious thing to do, the obvious. What we need these? Within what domain do we need these things to be unique? Can we constrain and say, so for example, we only care within a key, right? It doesn't matter if two different keys, abstract value holders for two different keys have the same ID.
It's key contextual, and what I don't want, if I go all the way to the more complex problem, which is clustered, I don't want collision between
clients.
Which means I probably want key and client ID and then something.
No, you don't want key. Key, you have it. You don't need to encode it in there.
Yeah, sorry. Yes, key is implicit. Yeah.
Right. So I think what you want is kind of a sequencer that is to the proper granularity. So in the case of off-heap, I would say on a segment base, right? Because then you also reduce the contention, the whole thing. And these could be like atomic longs, right? And just increment. That's good enough.
And that can be folded into the. So what you want to do is you want to add a method to abstract value holder that does comparison by ID, and you leave it up to the implementation to create the ID.
Yep.
Right.
Does it need to be comparable across stores?
Yes, it needs to.
Abstract value holder or
one thing
value holder interface?
Yeah, it gets, but that right? As soon, sorry.
Wait, Alex. You're saying by segment, but that's not true because we want comparison across stores.
That's fine. You move the value along with it. The authority is the thing that decides. In the case of on-heap, if you're by yourself, you don't care. There is nobody else. So it's the authority that decides that stamps the thing, that ID is the thing, and then you just need to make sure that this payload moves along the thing across the tiers, right? That's what you want. That's it. And then you just need, in the case of clustered, right? Because there's going to be multiple segments for the same key. Mm-hmm. Effectively, that's what happens, right? Actually, that's not even true. I'm talking nonsense. Never mind. In the new world, we can make. No, we don't want that. I'm talking really nonsense. You could have had the server be responsible for doing that, but it may introduce more chattiness, so then maybe kind of crappy. Anyways, it's not necessarily a problem.
That doesn't matter. You can. I mean, the client entities. It doesn't have to be overly chatty. You just need to know your client ID. You can, because those never get recycled.
That's not what I meant. I meant really doing the IDing on the authority itself, i.e. on the server. The problem is that if you do it that way, in strong consistency, it's probably all good. But eventual where things can take a little longer, they would either need to be lazily ID'd, which means more chat, or eagerly ID'd, and if they're ID'd from the server, you just introduce a huge bottleneck. So that's what I meant.
Cool. Anyway. You don't need to.
No, you don't need to. I said, maybe you could do it much simpler so that there are multiple segments for a given key. Yes, you can, but it's a stupid idea. So I sort of invalidate my own idea.
So how big an ID do you need?
How big? I don't think you need that much. I would expect because you can roll over, right? And
You can roll over as long as you can guarantee that that nothing still
still remains.
exists.
So there you go. Well, you can guarantee. Can you guarantee that ever? It's on the per key, right?
The only way you can know that is if you track the GC and recycle them.
Which you could.
Because in principle, there can be as many in flight as you can have threads running holding references to old shit.
And we can do that
In reality,
with a
you
low
wouldn't
watermark, and you're good to go. You don't need to remember everything. It's probably gonna even out, right? It's a cache mainly, and honestly, but what kind of sizes were you thinking about, Chris? So that I know.
I just had a sudden thought. There's something
Alright.
you can piggyback off here. Can you steal the thread ID that created it?
What are you getting at?
Because, so what I'm thinking is what you care about is races whereby you've got multiple threads putting things in, flushing them, faulting them, moving them around, right? Because what I was thinking was, well, what's the bound on how many live IDs there'll be at any one point in time? And I was like, well, it's bound in some way in the number of threads that are racing around inside this particular key, right?
True. Yes.
So if that's true, can I piggyback on the fact that the JVM provides unique IDs for threads and it already has to do recycling to make sure that's true, and therefore actually say what I stamp this thing is I stamp it with the thread that created it.
Yeah, but then it's still a problem. Because is it not? Is it good?
Yeah, you can't have a BA if you use the thread ID for the comparison.
So that thread created that, right? But then the problem is it comes back.
That thread dies, like main threads dies, and then it comes back. Yes. Well, it could even come back itself with being itself.
Doing something else. It feels like we ought to be take advantage of something there, but my brain's not working right at the moment.
Could be. I'm not sure. But so anyways, this still doesn't. So how big is the? I don't know. Is it what 32 bits?
Yeah, thread ID is an integer.
Right. So you would do what? 64. That's what I had in mind personally, because you still need to enhance this with the VM thing in the clustered world, right? So 32 bits will not cut it. Even if it does cut it at the single VM level. So, but why are you asking? I'm still not quite sure why you're asking.
I was trying to think
question.
if there was a smart way of auto-generating, leaning on some other part of the VM to generate the IDs for us.
Oh, there sure is, and we just probably don't realize and may never realize. We're not smart.
Because like stick a vicarious thread local in.
It's it's already in, isn't it? I think it's there.
Okay.
Not directly, but through statistics.
Only? Yeah. Okay.
Anyway, this seems like a solution. It's just we have to figure out what the correct generation strategy is.
Right. So effectively, what we're saying, we do that. We generate that. We introduce this concept of, I guess. So value holders become ID'd.
It's a value ID.
Sorry?
It's a version number on the value, really. Right? Effectively.
Yeah, maybe. Yeah.
I mean, it might not be orderable, but it's effectively a version. In fact, the simplest way to generate them might be to
what? Yeah, you can. I said, well, that's the example I took, right? Just stick an atomic long per segment and use that. And
or what if you
that's
just
good. On a single VM, that's perfectly fine.
What if you just do it by casing off of the current? No, because if someone removes it, you still need to have.
Yeah.
I was wondering if you could store the state machine inside the absolute value
No,
order
you
itself.
can't. That doesn't work. So
Anyway, we
Crap.
don't need to
So-
dig on this now.
that no, again, it's not the implementation I care so much. So we make value holders ID'd, versioned, which whatever you want to call that, right? That's the thing that he uses to do its equals contract comparison.
Yep.
Doesn't
Yep.
go to the value ever, right?
And does it need a creation time? No, we don't care.
Do I make that? Do I make that? Do I make that the equals really, or do I make that a special method on it?
I would make it a special method, and I would.
I would
You would do what, Chris?
I would do equals.
I was
would
going to
do
say the
it.
opposite of what Louis said.
Yeah, I would do equals and see what happens. That's what I would do.
The problem is we're gonna have subclasses and stuff, and so we don't want a real equals contract. We want our own kind of contract because we have subclasses of that type.
Why would the subclass?
Huh?
Why does that matter?
Yeah, why does that matter? The subclass only concern should be being able to do the smart stuff around updating the stats, the thing, maybe the
There's
serialization, laziness around getting to the value, things like that. It shouldn't care about that.
I mean, I would literally make the equals and put a protected method in for give me your ID.
You know what? I'm just going to try it and I'll see what happens. But long story short, we want that. If we need to change it, it's not the end of the world, right? But so we want that, and we want this concept of kind of an ID generator that then.
Actually, no, you don't want to use the ID because you want the heap version to be able to use object identity still. So you don't want to put the equals method in there because
Well,
you want the heap
you-
subclass.
Well,
The
that's-
heap, well, don't make it final. Let the heap version override the equals to do object equality.
Right, that's
Object identity.
what I said. You can. I would specialize that way around too, instead of.
Okay.
I would have the abstract be the most common thing, so nobody cares about ever again, except for the
Okay.
only because there you want to honor object identity.
Well, you don't. Well, it's
No, because you're gonna do. So what you're gonna have to do is cross implementation class comparison. When you do the
That's
flush,
not necessarily true. That's exactly not. It's
when you do the flush, you end up receiving the value holder from the caching tier, and
that
you need
should
to
be the
compare.
same type as you originally retrieved from you,
yeah, but
isn't
it's-
it? No, maybe it's not.
No, it's obviously not. It needs to
Yeah,
carry
we
the
have
same
a point.
ID. That's for sure.
Right.
But you're gonna create an on-heap value holder
Mhm.
that will steal the ID from the off-heap value holder it got for, at one point. Actually, I was looking at caching store. Do we even have that, or do we just pass the value? So that's going to be an interesting question.
Right, but maybe one thing where you may be confused is what we're talking about is it's actually you could have two on heap value holders, right? There is the one that are generated when it's the actual authority, which is the thing that get timestamped. So this is probably where you want to do the equals override. For all the others, you don't need to, do you? You
I
don't
just want to. Here's the
No,
thing.
you
All
don't
I
need
want to make sure is. Actually, no. Do you ever use the value holder if it's just a heap tier? If it's just a heap cache, are you ever going to do equality on value holders?
Nope.
No,
You'll never.
it's academic.
Then there you go. Then.
So they don't even need to generate. Well, you need to, well, your heap value holder never needs to generate an ID. It needs to be able to take one supplied
Well,
to
it's
it.
not. No. Sorry, it's not true. Because if we introduce that identity concept in the value holder, then we can, of course, short-circuit all the casing methods.
No, you can't. They're supposed to be valued. They're not supposed to be object identity based. They're supposed to compare the values.
Right.
Oh yes, and especially on heap, the values could have been mutated because it's only a reference.
I mean, you're right. You could use those things as a. It doesn't matter. You're not. The thing you're being passed in isn't one of those anyway.
No.
You're being passed a value, not an abstract value ID. You can't compare it to the abstract value.
True. Sorry, my bad. Yes, of course.
Yeah.
Stupid.
Anyway, the CAS operations are supposed to be object equals,
Right.
not referential.
It's really only my problem that I care
You
about.
realize that this version number is an object ID.
Right. I do.
We're partially rebuilding parts of Terracotta.
Yeah. Object identity to the people.
Object identity scoped beyond JVM. Sweet.
DSO was way ahead of its time.
Anyways, all right.
All
cool.
this is backwards.
We're one.
No comment on which it is.
Okay.
Well, I'll reserve judgment if I see Alex implement it.
Okay, so again, that's what we do, right?
When we say we do mean you, right?
Right. That's what we mean.
Just check.
He was speaking with the royal we, you know.
The royal we. Yes.
You should see me on my deck here. The dog is like totally in.
My dog is banished to Ehcache.
He's in the perfect it's a tough life kind of position. I'm not sure.
At least
much
your
better.
dog's a male and do that. My dog's a female and do that too sometimes. Like the least delicate position you can possibly imagine. Not very ladylike. Mine's in a crate.
And so when we do that, then suddenly lazy value holder, lazy deserialization, and that kind of stuff becomes potentially way more efficient because.
And the ID gets
We have to
saved
read-
in just like you do with the timestamps.
Yep.
Cool.
And then what we okay.
All right, so that was a small task. That's what we said, right? Simply update the data, because that I'm done with. That's the good news. Anyways, cool. I'll do that. Well,
to cache store.
Oh, I'm sure it'll lead to other problems. Look at the bright side. They're for me to solve. So they'll be buggy.
Yeah, so no, you get a value holder, so we can even be smart.
No, we wouldn't do that.
No. But I mean, no. We're passing value holder around between the tiers, so we can do stuff like if when I have heap of heap disk, that's gonna be weird.
If I had
Whatever, we'll see. Okay.
the smallest clue about what you're thinking.
Now, I'm thinking about trying to not deserialize
I
when
just
it's
had a
needed.
thought, by the way. The off heap might help you here, Alex, because you might be able to use the pointer address to help you out, because of course that gets allocated and it doesn't get freed until the mapping gets removed. It still doesn't help. I wonder if you might be able to lean on that a little bit. It's more ID-ish kind of thing going there.
I don't think I can. I
Anyway,
could,
sorry, no.
and it probably would be relatively safe, but it wouldn't be 100% safe.
Yeah, I was wondering if you can rely on some of it. It might be, but anyway, it doesn't matter. Let's not talk about that now. What else was there?
Could be reused, right? Could totally be reused.
Yeah, but not until after it's been freed.
Oh yeah, but I understand, but that doesn't help.
Because it could still be kicking around the heap. Saved as an
Maybe
ID.
not, yeah.
Well, you could end up doing an AVA in the same position.
Yeah, probably. Anyway, sorry. I should stop.
No, and honestly, I don't think, like for off heap, I'm just gonna go for a counter per segment. I mean, that's not gonna be the bottleneck.
No, that's fine.
No, especially when you anyway need to serialize at that point. So.
Well, right, but that's not the bottleneck that I care about. This is done outside of any locking scope, right? What I'm trying to say is that incrementing a counter within this lock or outside of this lock is not really important, even though I think I would do it inside of the segment lock.
Do it inside the segment lock because you don't need a type thing. You can just have a regular variable. Not even volatile.
Yeah, exactly. And that's not going to be much of a difference, given the other stuff that goes on during holding this lock. So that's what I would do.
Yeah. Sorry.
Yeah. Well, no, that's it actually then for me.
Was that the only thing
about my little problem? There was no agenda.
What did you think about that the way the changing the capacity at runtime discussion has been going. So the last thing would be to have something which is kind of update resource pools and takes a resource pools setting, and the idea is that, so for the moment we're not talking about changing the topology of the cache. So if you've got an on-heap only cache, you can just pass heap data. If you pass anything else, it will blow up. But if you've got, for example, a heap disk cache, and you pass an updated resource pools that only contains disk, it means don't touch the heap, grow the disk, or shrink the disk, that kind of stuff. And so we can internally build the proper full setup, validate it, and then apply it. Instead of that set capacity runtime comparable long.
And that goes away entirely.
I'm thinking yes, unless someone has a good idea for keeping it around. But
then you don't allow topology changes, which means if there's a resource pool currently in the configuration that's not, if there's a pool of a type that is currently in the configuration but is not represented in the updated one, it just stays unmodified.
Yes.
And if there's a type in the updated one that's not in the current one, it throws.
Yes. Yes.
Okay.
And for the rest, it allows us to build internally the final resource pools we would get, because we can, re-inject the ones that were not passed in. Yeah, we merge effectively, and once we've merged it, before even applying it, then we can check if we want to have rules like the authorities must always be bigger than the caching tiers and that kind of stuff.
I asked this question before. I know that this doesn't take into account ARC.
Mm-hmm.
Has anyone thought about whether this is just going to be completely rewritten for ARC?
I think it's going to be rewritten in the same sense that we're going to rewrite the resource pools manipulation handling.
Okay. So as long as you guys don't think, I just have a slight fear that it's kind of all this thought now is just kind of.
Yeah, This is.
I understand you want to eliminate tag debt and stuff, but
Risha back then is, I'm like, if you want to take some heuristics when somebody calls this long, comparable long thing, the runtime, I'm like, I'm fine with it. Try it, and maybe we'll delete it. I did give the heads up based on what we then decide to do with ARC. So yeah, my take is exactly that. I'm not too attached. Do something that you think is meaningful. I think the one takeaway that we want to have from whatever happens is to remember what the drives were behind all of those decisions. Those are more important than the actual result in the end.
Yeah, but we could have another approach, which is to say we ditch the existing method completely, and for the moment there is no question of being able to resize a cache at runtime, and we wait for ARC to be implemented, and we do it then.
Right, I don't like that, because ARC will not be implemented as part of the next release thing, so it's removing one thing. I don't like that, and I think you should be able to do it. And at least the thing that I like though about trying to put some thoughts into it is that you can, releasing it, then we can have it challenged by people maybe that our thinking was flawed there to begin with. So I see value in doing it. I'm just saying that I'm not too really attached to what the end thing looks like. I'm more attached of remembering what were the different drives behind certain decisions, so that we don't forget to consider these when we do the ARC stuff, and only being looking at it from the ARC perspective.
Yep. Okay. Good. So let's move forward with that then. And the drive for me being what has been discussed is being able to change the whole block as one,
right,
versus calling potentially different methods for each tier or what kind of that kind of stuff. And it keeps building on the abstracted tiers. If somebody wanted to add a resource type and that kind of stuff.
Woot. All right, I guess it's lunchtime.
Yeah, dinner time.
Way gone lunchtime.
Not getting serious.
Do we want to briefly mention
Sure.
our submissions, since we put in a whole bunch of stuff that's Ehcache related? Or do we not care?
Sure. No,
What
we
about
can.
it when we get in?
And well, before submission, then what I can mention is that I'm going to do in English this time the talk I did at Devox France, but I'm going to do it at Devox Poland. So June
You're not gonna do it in
27th to
Polish,
24th.
Polish notation.
I'm not doing it in Polish now. Sorry.
Polish notation.
Sorry?
Never mind.
Polish notation.
Are you going reverse Polish notation? Are you going to submit that to Devox Belgium too?
No, I don't think so. Once it's out in French and in English on Parlays,
They won't take it.
no, and I think for Devox Belgium, what's going to be interesting, if it gets accepted, is to talk really. Then I can relate what I've proposed to Java 1, which is more trying to explain
that's
the
my
kind of.
talk. I wanted to submit it.
Which one?
talk?
The one caching patterns explained, or
Oh,
That's
no.
that's Aurelian's one.
Not that one. The one about three selected features of Ehcache 3.
Ludwig's all about stealing other people's talks.
Design and implementation considerations that we put in place. What we just discussed, this is tiering. That's one of the topics that I want to discuss. And the whole, how do we make smart things when we have on top of each other data structures and that kind of thing. So kind of explaining the Montreal design on one side, discussing everything that went into, or is going to go into resilience strategy. And what was the third one? Gosh, it slips my mind. So more doing a talk around design of public APIs and features in a performance-oriented product.
Cool. I need to put some stuff in for Devox Belgium, probably. I don't know. So if I want to go to Belgium.
I'm planning to submit the talk that I submitted to JavaZone, which is about explaining cache patterns, how you should use a cache. Mm-hmm. The second one I'm hoping to submit is yours, Chris.
The Devox Belgium.
Yes, of Heap
I probably
Explained.
shouldn't submit it then.
Sorry?
I said I probably shouldn't submit it as well then.
If you want to give it, sure, go ahead.
Well, I don't know. We'll have to see. I
didn't expect you to travel to Belgium.
We'll be happy to have you in Belgium, Chris.
Well, I am from the UK, so it's not like.
Yeah, but at the moment you're not in the UK, so it's still quite far away for you.
Yeah, it is quite a distance.
And the third one I want to
double
is a joint talk with Spring Friend Mine.
Well, that's the one that's supposed to be done by Alex at Spring One 2GX, right?
No, I think it would be different. No,
it's going to be completely different.
The submission that was Alex could talk about it.
This is a really boring end to this meeting. Sorry.
Well, it's information about what you can learn about Ehcache 3 and its usage out in the world from conferences, if you're so inclined.
And all our talks are going to be rejected, so it will be completely wasted time to listen to us right now.
Well, mine will be rejected just because it's my name on them.
You're the only one having a Java 1 Rockstar Award, so...
That doesn't help in the far past, does it, Alex?
Okay, thank you, guys.
4 talks in a row refused. Right, cool.
Guess that's it then.
Yep.
See you next week.